Hello, welcome to our new Real Virtual tutorial series. A lot of things have changed, including our product name since the first start of Game for Automation tutorials, and it's time to make new and updated tutorials. I'm going to show you first steps from installation of Real Virtual I/O to the more advanced features like robot inverse kinematics, working with big CAD data, or programming your own logics for your digital twin. I'm assuming here that Unity is installed. It's best to also install the Unity Hub, which makes it easy to manage different Unity installations and projects. Within the Unity Hub, the first step is to create a new empty project by selecting New Project. Here you should select the 3D core template and you can give the project a name and select a location for your project. Let's select my tutorial. Now I'm creating the project and the project folder will be generated and Unity will prepare everything and start. This might take some minutes. After the project has been created by Unity, you will get this empty project. In the middle, you have got the scene and the game view. So the game view is what you will see later on in the ready-to-run digital twin. On the left-hand side, there's the hierarchy, which is the content of the scene. Here on the down-hand side, there's the project structure, what means all the assets which are within your project, so all the components, codes, 3D files and everything are located here in the assets folder, which is within your project folder. And on the right-hand side, we are having the inspector, which is showing you the properties of the components which you have currently selected in the hierarchy view. So for installing now Real Virtual I/O, we would need to import as a new asset or as a custom package, and I'm selecting here the current versions, so Real Virtual Professional 2021.13, and this will open the package of Real Virtual. Now you get the content of the package, so everything is new, and usually you should not change anything here, just click on import. This is taking some time, but after the import has finished, this welcome window will open and you will get automatically the demo scene of Real Virtual opened. I recommend to make these 3D icons very small because usually we don't want to see the camera icons, and you can now run the demo scene by clicking here on play, and this will automatically open the scene view or the game view, sorry. And here, if you deselect low resolution, you will get it in a higher resolution on your screen. And that's how the compiled and built digital twin, which you could deploy as a Windows executable or as a WebGL file or as an Android executable, is looking like. While the simulation is running in game view, you could also check the components in scene view, click on them and look on the inspector values. For example, here you've got the drives with their properties. But before really checking the demo scene, you should make sure that Real Virtual is really installed as it should. First important thing is you should have this main menu bar here, so the Game for Automation menu, which has been the former name of Real Virtual. It will be soon renamed to Real Virtual. So you need to have this Real Virtual main menu here. Another thing is that after the import of Real Virtual, if everything is okay and there's no collision or compile errors, which you could see in the console log because of any collision with maybe things which you already had in the project, then the standard settings of Real Virtual should have been applied to your project. And you can check that, for example, by checking the layers. You will get here some additional layers which Real Virtual is needing for its correct function. And if you don't have these layers here, or you get an error in the console log, you should first check what's creating the error. So maybe you've got a DLL inside your project already, which is colliding with Real Virtual's DLLs. And after you checked all these errors and you don't get any errors, you can select again here Game for Automation, apply standard settings, and this will set the standard settings for layers and so on. But usually, and in an empty project, it's always the case, you don't get any errors and it's just already set like that. So setting the standard settings is only necessary if you get a compile error while you first imported the project. So we imported in an empty project, so we are totally fine here. If you purchased Real Virtual over the Unity Asset Store, you can import it into an empty project by selecting here Open in Unity. And this is opening here the access to Real Virtual over the Unity Package Manager, and you can import it by selecting here Import. That's only the case if you purchased Real Virtual on the Unity Asset Store. Otherwise, you can install it by the download link which you received within our invoice. So if you purchased it over the Unity Asset Store, you need to select here Import, and Real Virtual will be installed into your current project. And same as the manual installation, you just need to select here Import, so just don't change anything here. Selecting Import will import or update Real Virtual into an existing or into an empty project. Now let's check a little bit the demonstration project we are delivering. You can always open it by selecting here the Open Demo Scene button, and this will open this demo scene. We can start it by pushing on play, and the game window will open. I usually make this game window smaller and put it here because during the design of the digital twin I usually work within the scene view. But let's first look into what you get into in the game view. So we can rotate by selecting the right hand mouse button, and we can zoom in and out by selecting the middle mouse button. And we can pan by pushing the middle mouse button. You can switch between an orthographic view or a perspective view by pushing here on this icon. And in this demonstration model we included some standard camera views which you could select here. Additionally, you've got here a kind of an overlay window showing you the orthographic perspective, and you can zoom by also using the middle mouse button if you're over one of the orthographic perspectives, and you can also pan like in the scene view on the game view to get a view of the thing you would like to see. Turning it off is done by clicking again on this icon, or you can make also this view bigger or smaller. If you would like to have a first-person view on the model, you can click here and you are in a first-person view, and you could change your view direction by using your mouse, so by pointing to any direction. And for moving around or walking around, you can use the WASD keys like usual in games. But mostly I'm working with the normal CAD-like navigation which we are having here. This button can be used later on for connecting to real PLCs or disconnecting. And here we can change the visual quality level. You see we have got here cycle time or calculation time for each graphic or each image of 7 milliseconds. So in very large models we can go to a lower quality level, for example without shadows, which will increase the performance of your system. But for this very small models, we could always stay on the best quality level. Another thing which is new in the latest versions is that we can have a selection mode here. And so in the selection mode, things are highlighted, 3D objects which are detected by the mouse. And if you double click on it, you will get a rotation point set here on this component, and you can rotate around this component, or let's set the rotation point down here. And by double clicking, I'm setting this rotation point and focusing the component. By pushing escape, the selection is reverted. Now let's check a little bit how this model looks like. First of all, in scene view also we have during edit mode this overlay window here. This overlay window is providing you the most important functions for Real Virtual directly on these buttons. It's context sensitive, so it changes dependent on what you are selecting. It can be turned off and on by pushing on F1. Here we have got 3D components which have been imported from a CAD system. And to these 3D components, for example here on the handling, we are having the scan tree. We can add here to several hierarchical structures drives. And these drives are at the end moving these axes, and by selecting here several properties like direction, you can change the directions of the drives. To a drive, there's a so-called behavior model attached to. So we are having several behavior models here. You can see most of them here. And this behavior model is providing the connection between the drive and the PLC signal itself. So here we have got a so-called destination motor, and if we click on this connected signals, we're getting here the signals which are connected to our drive. So currently here it's a deactivated Siemens S7 interface, because in our demonstration model we don't deliver a real S7. More or less the whole PLC code is scripted in Unity or Real Virtual Code, but we are still having here signals, and these signals are controlling the drives, and the signals are connected to scripts, for example here, which are doing the control of this demonstration machine by changing the drives, by changing the signals, like a real PLC is reading in the inputs and controlling the system by changing the output signals. So here we have got all the signals, and on the signal itself we always have also some information where the signal is connected to. So we can open the gantry here, and by selecting the gantry we see here all the signals which are connected to, and the connected signals are shown here in yellow. And by clicking on the signal itself is highlighted. While the simulation is running, you can see here the signals and how they are changing over time. You can even force signals, so you can change their value to a different value than they are controlled by the code. So for example, I force the scan conveyor sensor to false, which results in the situation that it's always false and the cans are falling down because the conveyor isn't stopping. I can turn off forcing by clicking here on this sign besides the signal value. For stopping the simulation, you can push here on stop, or you could pause it and the simulation is paused at this position. Within the scene view, we also have some additional abilities. There's an overlay window here. For example, we could increase the speed of the drives. The physical simulation is still on the same speed. Or we could reduce or increase the physical simulation speed. You see these cans have been fallen down because of the speed increase we made before, but by increasing here the time scale, the simulation will run faster. So the real time, if we check here, is running much faster than the real time. Okay. So that's basically all concerning how we use it in scene and game view. By selecting here info, you'll get some overall information or some links concerning Real Virtual I/O. First of all, you always get here the current version number which you've installed. You can open the release notes which are online. You get our release notes, and basically these release notes are within our documentation page. So here's the full documentation about Real Virtual and all its components. So for further questions, please always check our documentation page. You'll find it under doc.realvirtual.io. Usually we publish news about Real Virtual in our user community. We are having a LinkedIn user community. If you're a member of LinkedIn, you can open it here and get access to our user community. Give us please a rating if you like our solution, and this would be very nice. Dependent on if you are using a starter or a professional version, you are having here functions available or not. And if you are having a starter version, you can get here a link to the professional version on the Unity Asset Store, and it can be purchased here. That's all for the moment for our first tutorial. This tutorial was about installing Real Virtual I/O on top of Unity, and I've shown you the basic utilization of the game and scene view, and some information how the demo model is built up and structured. Next week you'll get a new tutorial about building up your first own digital twins. Bye bye.